Yo, so what up everybody? So going off the last video, we have this function here. And we can actually just pull the same thing to check it with a minor difference. Instead of C flow, you can do C Q within the parentheses, and it gives us the array we want. So there's a few more steps left and then we will be done. So now we're going to define another function, probably the last function we're going to define, in which we need the internal pressure, since we have three unknown variables, which are the three internal nodes that we need to find. So internal P, this can actually go inside the parentheses, C press, C flow. Where do you see flow? So let's say net internal Q. And what we're going to return is going to be net internal Q. Actually, no, it's not. It should be this function here. And we're going to need the internal nodes. But we don't have, I don't believe we have internal nodes as a thing up there. So we're going to have to define that. So we're going to have the internal nodes is a group within like a sit or a set. So we're going to have to do that first. Let's say internal nodes. So equal to it's going to be a list, set, n nodes. I'm trying to think. Let's see, range minus. It's going to be the external nodes. Let's see. It's not that simple. I'm going to have to add something. I believe it's set as well. Caps lock on. Here it says unexpected parsing. So I did something wrong there. I believe what I did wrong. I didn't put the in the list. So let's say check out internal nodes. One, two, three. So that is exactly what I want from there. But we are missing some stuff on the top that we need to put in as well. So we should already have a heads equals NP, since we use this a decent amount of zeros. So in nodes. So now we need the external. So heads, say external nodes. It's going to be equal to external pressures. So you get external P plus, I believe it's the height. So the height of external nodes, I believe. So external nodes. Let's see. Not sure this is going to work here. So, and then we go back down here, get internal. Then you get internal. Stop it. Nodes is equal to heads internal nodes. Can't see. Divided by rho, divided by G plus Z. So the positions of the internal nodes. So I believe that's right. So now that we have that, we can do an internal we need a pressure guess now. Internal P guess, which is going to be equal to the NP dot mean of the internal I actually think that's internal P right there. That's my bad up there. So where's internal P? Internal P. I believe this is also internal or external. It's NPP and external mean. I don't think it's heads external nodes. And then it's another guess. It's not internal pressure guess. This is a P guess. That's the variable. And you're going to get the mean again. So NP mean, this time it's going to be internal nodes. Heads minus Z internal nodes. This is going to be divided by. So this should be internal P guess here. That's my bad. Internal. And this should be internal head guess up here, since we're going to need the head guess to find the P guess. So let me get rid of all U. So it should be internal head guess. Minus Z of internal nodes. We'll put this in parentheses. Oh my goodness. Hopefully. So okay, I need to use a root function. That's what that's for. So you root internal, not internal P. Think of internal. I know it's internal P guess here. So internal P or net. I think it's net internal Q. That's what the function is. So net Q. Local variable. I believe it's because this should be heads internal nodes there. And yep, that's part of it. But now we gotta get to the other part. So all these were guesses above. Now we can actually find the calculated net flow. And the flow's going through out of each pipe. So we just can do the same thing above. So calc. C flows head. C flows head. Let's see if I run everything first. I'm just going to copy and paste that because I know. This is one of them that you want. And this is the other one that you want. And these will get you the flows going in each pipe. So all 6 pipes. And these will get you the total net flows. And you see how the first one's negative since it's flowing down all the different pipes. And on one of the other pipes it's negative as well. And this is how you find the net flows by coding for pipes.